All right, welcome back to the drive-through. Hungry? Stop by the deli. Make yourself a sandwich. Extra cream cheese on your bagel sandwich today. Okay, so we're doing question number 69 from 10-1, Tuesday's assignment. You can read it. One of the things with this problem that would probably confuse you is this term right here. Okay, so we'll get to that when we get to part B. Let's widmapoi. So if I just sketch y equals x cubed, it's like one of that. No, that's close enough. Okay? And we want a unit vector, which is a vector length or magnitude 1 from the point 1, 1. Okay? So this is going to be our first time that we've even used calculus so far this year. To find the unit vector at that point parallel to it, we need to find the slope of the tangent. So that's going to be, there's the equation for the slope of the tangent lines. And so at the point 1, 1, okay, our slope is 3. So what we're looking for is a unit vector at this point. Okay, so we know that if the slope is 3, it's going to go over 1 and up 3. So we would write that like that. That is a vector that is parallel to our graph at that point, but it's not a unit vector. So the magnitude of that, let's just call this vector u for now. The magnitude of u is 1 plus this radical 10. So our unit vector parallel, so for part A, our unit vector parallel to the graph at that point would be 1 over radical 10, comma, 3 over radical 10. Okay? Now, this is what's weird about normal. It has two different connotations in multivariable. Normalizing something is making it a unit vector. Normal to something is orthogonal, which is also perpendicular. They just like to make themselves seem smart, so they use a lot of different words that mean the same thing. So now we're looking for this. Now this is going to end up being a really key component of this class, because you can see that we're just breaking things up into their parallel and perpendicular components, and if you've ever taken physics, you know that's an important thing. So imagine that the slope of this one has to be negative 1/3, okay? Because perpendicular lines have opposite reciprocals. Put your thing down, flip it, and reverse it, if you will. So I'm going to go right 1 and down 3. So this vector, did I do that right? No, right 3, sorry, right 3 and down 1. Thank you, thank you. I knew that wasn't right. So this vector will be 3, negative 1. So right here, this green vector is normal to the curve at the point 1, 1. But it's not a unit vector. Notice it has the same magnitude as our other vector did. So for part B, we'll take our green vector and we will normalize it, which means make it a unit vector. So it's going to be 3 over radical 10, comma, negative 1 over radical 10. And that is that. Boom!